There he is. He's come out to see the installation and to see what's been in his yard since he went in the house 30 minutes ago. It's Dan the man. What are you doing, Danny? Where are you going, Danny? What are you doing, Danny? Welcome back, Sawmill, everybody, on a nice chilly Sunday morning, November 2nd on Cape Cod. I am not going to do any milling today. I'm going to watch some football, but I want to knock out a little project because we have the post and beam installation going on for Brian Carroll fairly soon, and it got me to thinking. I was thinking about cutting the 8x8s and whether I was just going to do it with a chainsaw. I've got a million different ways that I can do it. I could do it with big Japanese saws, which takes forever. You can cut them with a $1,000 beam saw like this, but even this at 16 and 5/16 won't cut all the way through an 8x8, true 8x8. And I decided to take a chance on a product to hopefully turn this into something that's better than that for cutting beams. Now, no doubts, the Makita, I've done some monster joinery and stuff with it on outdoor high-end projects that I've done over the years. It definitely has its place. There's no doubt about it. But this right here is going to make this saw cut deeper, which means I can cut a 12x12 with this. And if I can get this thing set up right, I can cut a 12x12 square with this. So that is the journey that we are embarking on this morning to see if we can turn this Harbor Freight Hercules beam cutter into something that will cut deeper than this and possibly even better than this. I don't know. Most of you have never run one of these before. Okay. Most of you have run one of these before. Now, this is my tried and true. I have built a lot of buildings. I have built a lot of decks, a lot of structures with this skill saw, circular saw. And to the point where my handle's worn off it. But truth of the matter is that since I got my battery DeWalt, my big battery DeWalt, I never use this anymore. It just sits in a bag. And sometimes I bring it on a job site as a backup. So this saw is a perfect candidate for that beam cutter because it never gets used. These right here, one of the limitations to this saw, if you have never run one before, is voltage drop between where you plug it in and where you run it. Sometimes out on a remote job site where you've got to run power to this any distance at all, kind of like where we are out back here, it really drags these things down. So what we're going to do is we're going to install that thing on this, and then we're going to get a beam up onto some sawhorses, and we're going to make a cut with that, and we're going to make a cut with that thing on this, and we're going to see how they compare. I think it could be interesting. So let's get to trying to put this thing together. So I'm going to go handheld here for a second before I clean this bench off and get to the installation side. This is the package that we picked up. They are about $74 from Harbor Freight. You can see the Harbor Freight item number there. Up to 12-inch capacity, securely mounts to worm drive saws, both conventional and worm drive saws, guide bar stability, blah, 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 blah. Low profile, anti-kickback. I'm hoping that chain is the same chain that I run on my climbing saw. It does have an oiler on it. Says fits both conventional and worm drive 7 1/4. Gives a whole list of ones that it supposedly fits, and skill is on there. Legendary performance. Whoa, that's going to be pretty special. Comes with a set of instructions. Comes with a little baggy thing of some tools, a couple of parts. Looks like overall it's pretty simple to put on, but let's kick it in the nuts and see what we can come up with. All right, so the way this is going to work, or the way I'm going to try to do this, first of all, I'll try to give you the best views I possibly can. What I'm going to do is I'm going to bring you over, I'm going to show you in the instructions what we're going to be doing, and then we're going to do it. This first part here, so I get you a good view, is this section right here. Basically, we're going to take the saw blade off. We're going to extend the saw all the way up to its full height. We are putting this on a circular saw, so we have to mount this mounting plate on the side of the whole setup here, slide this thing down through the saw, figure out which flange setup we need for our arbor, and I think that's pretty much it. It also comes with this hinge setup here. It looks like that hinge setup is for worm drive saws. So I don't believe we'll be using that. So all we're going to use is this little mounting thing here. This mounts to the side of this, and we're going to go through these steps here. Now, if I get my head out of frame, that's probably a good thing, so you won't have to look at my head. And I apologize for that. But I'll tell you everything I'm using. Now, you can pull out your little spanner. That's with the saw if you want. Now, supposedly, we have to take the blade off. Obviously, we have to take the blade off. And it says to take the inside flange out. On this saw, that inside flange does not come right out. So maybe we don't need to take it out on this model. We're going to find that out. So none of these fit that. So I'm assuming the one on the saw does. We got to get this thing all raised all the way up. And from the supplied hardware, determine which correct size arbor bolt. Well, we won't be able to do that till we get it on the saw, probably. Attach the mounting bracket to the beam saw, so it shows in the picture like this, and it shows that mounting bracket going on, attaching on the front side like that with an M6. I don't know if this is going to have to be slid around, so we'll just finger tight this thing for a second here. Don't exactly know what the right orientation is going to be for this thing or what, or if it's going to have to be moved in and out. All right, we're going to slide this thing down through this hole opening. All right, so Mommy and Danny just came out, so I have Danny out here now. This thing slides down inside here, like it says in the directions, and it looks like this bracket on the side here is going to mount underneath your saw blade guard, I guess to keep it from coming down and to shore this thing up. But one thing that I see on my saw right away is there's a bumper in here that this hits against that's in the way to keep this thing from mounting. So what we're going to do is we're going to pull that bumper off. Take that off. Wait. And now we're going to see if we can get this thing down inside there. It's got a slided clutch on it, kind of like a standard circular saw blade. And yeah, she slides right on, so that's good. Looks like that is the position. Slides right on. And it goes all the way in flush, so that's a positive. It looks like this thing has got a mount in here. Let's see if we have the right, just like that. Just going to see if I can just screw this thing in here just to kind of hold it in place for a second. This is the mounting screw that is going to mount this. Now, I'm not sure if the flange, if any flange goes on here or not, so we're going to find that out in the directions in a second. So this thing is just kind of stuck on here right now. It is on the arbor. This thing's stuffed up out of the way. We're going to have to go ahead and totally mount this thing, I assume, next. All right, so what it's telling me to do, I'm just looking at the instructions here. There's not much to show you here. It's just a picture. It wants me to put one of these little spindle bushings in there, and we're going to have to see how those go in there. Actually, I'm going to test this one right here. They've got a conical face on them, and I'm not exactly sure I understand why it's got a conical face on it. It almost seems to self-center something. I don't know that it needs that. It does move around a little bit. Yeah, so all right, so let's just go ahead and do that. It does move around a little bit. I can't see that the conical feature would be facing out. It doesn't say whether to face it in or out, obviously. But I can't imagine why it would be facing out. So let's just go ahead and face it in. And let's see how that seats down. I can't imagine why it would be conical if the cone wasn't going in. But at the same time, it does hold it in place there. Okay. Let's just cinch that down. Wonder if my standard saw, yeah, it does fit it. It says finger tight for now, so I'm not going to tighten it all the way down, but my standard saw wrench does fit that. We got to get this mounting thing done here. Apologize if I get anything out of order for you guys or whatever, but obviously that needs to go there. I'm just going to cinch this M6 screw down. This one needs to come out and go into this hole here. And it is 10 Mickey Mouses. Okay. And we'll snug the 10 Mickey Mouses down on the back side. All right, that holds that in there. This is in here. Secure that. Align the beam cutter assembly to 90 degrees to the saw's base plate. Hold in the spindle lock. Tighten the arbor bolt. Do not over tighten. Wrench tighten the M6. Secure it to the beam cutter assembly. Okay, so I guess what it wants me to do is it wants me to orient this so with using this and this, so this part of the saw is 90 degrees to the base plate. Don't really, I guess that makes sense if you were going to be cutting tenons or something with it and you want it to cut to the same spot. So let me get you guys a different view and we'll do that. See how far out we are first. Just using a regular speed square here. I don't see how it could possibly be any closer than it is. I mean, it's perfectly square just the way it is. I guess if it wasn't square, you would adjust this to where you could move this. But using a speed square, it is pretty damn good. I mean, it's dead perfect. I don't know what else to say about it. So let's see what this thing says now. Hold it to 90 degrees to the base plate. Hold the spindle lock and wrench tighten the arbor bolt. Don't over tighten. And then wrench tighten the M6 nut to secure the beam cutter assembly to the circular saw. Oh, wait, I think this might be talking about 90 degrees this way, and that's what that M6 is there for. So you could turn it, and that's why that's conical. Gotcha. Okay, let's check that out. Let's see how far out we are this way. Wow, it is, guys, I don't know what to say right now, guys. It is so close to perfect. So close to perfect. Let's check it with something a little bit tighter tolerance. Obviously, if you're using a saw dedicated to just this operation like I am, you can set your 90-degree stop on your depth, on your plate itself to get that right. To be honest with you, this saw was never right. It was always like 1 degree off. So I actually have it set square at like 1 degree off. But right now, this is good. Let's see how. Well, that's interesting. So this is going to be fun, guys. I'll show you something, a couple things. So number one, that's going to be fun to fill there. I don't know how the heck you even would. You're telling me you're gonna have to take this thing off to get that thing to fill that thing? Or I'm gonna have to get some sort of a tube for like bar and chain oil? That's silly. The other thing that I see is that the riving knife is not in line with the blade. There's no adjustment to it, but if you look down the riving knife, it's bent a little bit. So I'm going to have to bend that over until it lines up behind that, somewhat anyway. I don't know how the heck we're going to fill this thing. I mean, maybe there's something I'm missing here. Maybe you just have to pull out those 2 screws and you fill it and you put it back on. It's just 2 little screws there. We'll see what the directions tell us. All right, so we're going to make a couple of cuts with this thing against the $1,000 beam saw. We're not comparing apples and oranges here, guys. That $1,000 beam saw, I have 2 blades for it. I have one that's just a general purpose. I'm cutting whatever. Then I have a perfectly sharp Freud blade that I only use for very special circumstances, like I'm cutting joinery, angles, big stuff, thick stuff that I need it to cut perfect. So for the most part, I keep my general purpose on there. It's been used quite a bit. I have 150 feet of cord run out here. I can tell you that's going to take a toll on dragging that thing down. I don't think it will take a toll on dragging my little saw down. think my little saw will operate perfectly fine. I did blip the throttle on the little saw a little bit, and I do get some shake at very low RPM in that one. We're going to see how that manifests itself. The other thing is that this 5x5 right here is not perfectly straight. So our ability to check square is going to depend on that. So we're going to have to see how that comes out. But let's go ahead. We're going to run the big $1,000 saw first. We'll cut through this thing, and then we'll run that thing a few times. The shake in the blade, there's a possibility that I have that conical flange on backwards. I don't see how I could, without the conical flange, I don't see how I could have adjusted the side to side on the blade without using the shoe. If I think that is the cause of what's going on, then what I will end up doing is I will end up putting it back on the other way and then adjusting for square with the shoe and see if that takes the shake out of it. It almost seems like it needs another bushing or something. I'm not sure. Maybe I don't think I have the wrong size screw in there. It was the only one that it just fit through the hole. So I will have to check that out. But let's try it and let's see what happens. So we're going to run the big saw first. And like I said, I think that voltage drop's going to be an issue here. So this is cutting through pine. It did a good job. You know, it cut straight. It did drag it down a little bit on this little 5x5, which is to be expected with 150 feet of cord on that big motor, because it does drag down. So let's try the little one. I'm just going to do it by eye. So there is quite a bit of tear out, obviously. I'm going to go ahead and just try to check if the square, let's see how square it kind of cut. It's not square. It's not square in either direction. Let's make another cut with it. I don't know if you can see that, how bad that's shaking around right there. And I'm not sure what the cause of that is. So that's going to be something that I'm going to have to figure out. Because if it won't cut straight, then it's not worth doing. I'm actually going to make a line and try to follow a line. Let's just see how it marks up on the side here. Like I said, this isn't exactly straight. So if I eyeball down it, yeah, there's a wicked bow in it. So it's going to be hard to check straight with it. Now, one thing that I think is going to be hard for me is going to be to follow a line, because I can't see from the other side. Now, I'd have to get this down lower. Let's just go ahead and run it. You're going to have to be very, very careful not to nick your cord with this thing. It is hard for me to follow a line because it kicks stuff straight up in the air. It cuts backwards, so it's kicking stuff straight up in your face. It's cutting out like this, and I didn't even get close to square this way. I did not stay on the line well. I'm going to spin around and cut it back this way and see if I can see the line better from the other side with the light. I think there's way too much wobble in this blade. To be honest with you guys, right now, you know, it almost cuts crooked enough to be unusable. That's going to have to be something. It's almost impossible for me to draw a square line here because this timber's all messed up, but let's try it right here. Yeah, good seat there. You're going to have to be very, very careful with cord management on this. So I'm going to see if I can see it from the other side here. Let's see how that cut came out from the other side. Well, that cut's pretty square. That cut's pretty square both ways, actually. That's interesting. You know, could it be my ergonomics, the way I'm holding on to it? Or obviously, I don't know if you guys can see this, but there's a little pin prick out right here. So if I ran the saw on this, it would cause it to dip because it's a little high. Spot where it's not high right here, there is, I can see light under this, that this isn't straight, but this is cut. This is pretty square here. And it's pretty close this way too. I think maybe a couple things. I will have to mess around with it to see how I can mess with that wobble. And I think when you're cutting with it, you've got to get yourself in a real good ergonomic spot. We'd want them lower than this. And it's really hard for me to follow the line on that. I think what I would actually do, I think I would measure the distance from the outside of the kerf to the outside of this plate, and I'd probably draw a second line to try to follow. All right, guys, here's an amendment. I did a couple things to it and made it a lot better. Number one, I took out that inside flange. It didn't seem to want to come out when I first did it. I took it out. Now it seats more on the saw, and it seems much more rigid. Number two, I turned the conical. So if you see these things here, they have that conical feature on them. I turned that out so it's sitting flat against the flange, and I tightened it up. It took 99% of all the wobble out of it. And then I adjusted my plate until it was square, or at least as square as I can measure it with what I have out here. So my stop on my plate at 0 is square on the saw. We're going to try another cut with it. And I've got a different beam. This is going to be a little bit harder to see just because I'm down on the ground down here. These have to be cut off anyway for a customer, or he's going to cut them off. What I did here was the inside of my blade, just like on my circular saw, is 5 inches over to the edge of the plate. I put a line 5 inches over so I can follow that. Let's cut this thing off. Let's cut this off and let's see how square it comes out. These beams are nice and straight and square. And we'll see if there's a major difference. Hopefully it's not going to hit the ground here, right? Nope. So I can line the edge of my plate right up on that line, and then I can watch that line when I cut. Now, just to let you know, I don't feel any resistance in the saw at all. It cuts that smooth. Let's see. I can tell by eye this came out way better. Let's just see what it looks like. It's really, really, really close. And it's really, really, really close. This is completely acceptable. I was wrong. I didn't have it installed right. It did say to take the inside flange out. It just felt like when I tried to take it out, it wouldn't come out. And that, when I took it out and put it back on, it was way more rigid in the setup. This is very, very close. It almost looks like it needs to go like that a little bit. Almost what I did to it, I need to undo. And I think that if I saw that consistent result a couple times, I could fix it with the shoe. Let's go ahead. Let's double check it. Let's do this. Let's cut the end off this one. So let's make a line. I just want to be as accurate as I can be. Let's make a line. I'm going to measure over 5. So I'm going to burn an inch. Measure over 5. Make a line. I'm going to cut this one and see if the result's the same. That would tell me that I needed to undo what I did in my adjustment. All right, let's try it again. So I'm right on that line. These are true 8x8s, so this is a bigger cut than we were making before. Yeah, I'm seeing the same thing. I'm seeing that it's actually going to tilt. It's got to tilt more. The blade has to go. It's just a little bit, guys. It's not much. It's showing me that the blade has got to go like this more. Let me adjust it again. Actually, you guys stay right there. Okay, I'm going to put a little more adjustment. So this needs to go like that. If I can see that in a square. Oh yeah, I can see it in the square. It's not even close. I think it's pretty close right there. Let's double check it again. Yeah, it looks pretty close. So let's make a line over an inch. We'll take another inch off this. That's all I can take off. Doesn't even need to be, yeah, it's going to be an inch. All right, let's cut it again and check this one for square. All right, let's see how that did. It's way more stable now. Let's see how close we got it here. Oh, that's perfect. That's perfect. It's dead perfect. That came out great. It's dead, not square. All right, so right now, at least I'd feel confident using it. Yeah, it's really square now. All right, well, I actually feel confident using it now. I don't think that oiler works. I'm going to read up on that and see if, maybe you're supposed to squeeze on it or something. I don't know. It hasn't gone down in fluid. I don't see any fluid on the bar or anything like that. I think I'd just keep a little squeeze bottle if I was cutting a lot of beams, just to put a little bit of bar and chain oil on it every now and then. But we solved this problem. So now it cuts nice and straight and square. Yeah. Yeah. Yeah, it's beautiful. And it's not jumping around like it was, so I'll put this in there somewhere. It's a keeper now. The way it works right now, it's a keeper. It's very sharp. I did check to see if I was going to have to file it. It's very, very sharp. It was ground nice from the factory. And I think I got a keeper. And go 12 inches deep and cuts better than you could possibly do it with a chainsaw. So the only drawback is having to mark over, or you could just simply make a couple little dots and clamp your speed square there, something like that, or hold your speed square there while you're doing it. Right now, keeper.